We are making history today. This is the first one-day proper hardware hackathon in the history of the world.
We had a hardware hackathon, meaning students grabbed a kernel from Mac Suite and partitioned the hardware to the software, took the software, wrote it up in OpenCL, mapped it first to a software emulator and then to an FPGA. We had 2 FPGAs in the room.
So the goals were to give every single student an end-to-end accelerator build experience. You know, what does it mean to build a host program, pull some code out of it, stick it into an accelerator, interface the two together by some means, specify the accelerator in some high-level language, build it, simulate it, debug the simulated version, and then at some point do synthesis and put it on the hardware. So everybody got that experience. And that experience is, it's both the mechanics of doing all that, the way things work today, but also sort of the pain points and the tools. Everybody got to experience that as well.
And I think OpenCL is great to look at because I don't think it's super impressive. It's kind of like a baby step in the direction you want to go in. Because it's data parallel, it has a lot of, you can express it in hardware fairly easily. But Xilinx has really run with it to say, you know, this language you can express your hardware components in as well. You want to mix people up. Again, you want to work with people you haven't possibly worked with in the past. And we want to have a kind of a mix of hardware and software expertise in the groups.
My team, we had 2 hardware people and 2 software people, and the discussion between hardware and software is just really intriguing. And you know, eventually we got it to work on the FPGA, so that was a big happy moment for us.
We've got today, we're going to do software emulated development, and it's pretty efficient to do software emulated development, and we got debuggers and all this stuff. And then in the afternoon, when you want to come test, you can come over here and do what we call a hardware excursion. So you can do a full synthesis run, and you should be able to do that in under 30 minutes with the size of projects that we're going to work on.
Oh my god! What are we doing?
We were porting vector search from Mac Suite originally. And so our biggest challenge was originally to just get the interface working. Instead of trying to get the OpenCL to work, we just wanted to get the interface of how to communicate the wrapper code actually to work. And that turned out to be really difficult. So we had our 5 teammates, we split up and we tried to get it to work until eventually at the midway point, we decided to switch and do what they actually asked us to do and take Mac Suite and port it.
And we ported Viterbi, which is a dynamic programming algorithm, from Mac Suite to OpenCL. So the very first thing was that we approached this as a very software problem, in that so we would make some changes, try to run some tests, debug using that, right? But that didn't work out very well because the debugging time was extremely slow.
Overall, we thought it was actually a pretty good experience. We thought it was a good, challenging hackathon, and it was good. Not too hard, not too easy.
So it was painful, but it was a great experience. We learned a lot about how the toolchain works. And in the future, something similar would be great. If we repeat something like this, that would be awesome. Or if we just learn some different kind of toolchain.
It was a really great experience. For me, sort of the best experience was walking around listening. I mean, there were 9 design teams going at it for all day. It was really exciting.